Okay, we need to do a quick run through on an algorithm that they talk about with finding roots of an equation by looking for changing the signs. You might know it more as trial and improvement, and it is basically a trial and improvement method. And what we're looking for is, if I put in an equation, where does this equation enter across a line? And we do it by finding the values either side of a key point and keep trying to zero in on them to find out exactly where is that solution. So if I put in the function x cubed plus x minus 3x plus 1, we get a graph, and we've got a number of roots to this. One about -2, one about between 0 and 1, one between 1 and 2. And what we're going to try and find is find the solution between 0 and 1. So find the root between x equals 0 and x equals 1. So we're actually hunting for this value here. So sorry, I missed off the equation over here. So it's x cubed minus 3x plus 1. So the root is of a function, and all we're actually trying to say when we're finding the root of a function is where is the function output 1, i.e. where does it cross the x-axis. I'm going to show you a fast technique. If you've got a table function on your calculator, the Gaussian, you can use table number 3 and you can type in your equation. So we've got alpha to give us x. We want to do it cubed. Mine has a cubed button, but you might have to use a power button to do it. Minus 3x plus 1. I don't know why I said equals 1, it equals 0 plus 1. And what this does is it will create a whole table of values for me. The start is where I would like to, so fx. So the start value is where we would like to start looking. End value is where we'd like to end looking. And the step is how would you like to increase your values. Now there's a limited memory on these calculators, so I tend to keep it so that there's only going to be a limited number, only about 10 places, and I try to do it one decimal place at a time. It's the most logical way to do a hunt by trial and improvement. So let's look for the solution by doing the start 0, end is 1, and the step is 0.1. So now what we get is a series of values where it's tried to, it actually calculates our function points, and it goes from 0, 0.1, 0.2. If I scroll down, 0.3, 0.4. Now what's important in here is finding where does it actually change sign. So we've actually found a list of numbers there, and to find the root what we're looking for is the change of sign. So I can actually do a table of values and say x and fx and sign, and we can find the root by a change of sign. As long as the function itself is not a reciprocal curve, which could go off to infinity, the only way for us to go from negative to positive is by crossing the x-axis. If I was to do 1 over x minus 3, that one never actually has a root, but it does at 3 cross the x-axis, and that may look like one where the value is 3. At around 3 you can actually find a value. The key point is that this has a reciprocal component, and when you see those you need to try and deal with them as early so that you don't actually accidentally cause yourself a problem. They're normally fairly obvious. Certain functions may give you a problem. So we've tried the value 0. Come on, give me the pen. So we've got 0 and 1. And at 0, I had a value of 1. At the 1, my value is -1. So we've gone from positive to negative. So there's a root in between. Now, you might hint by doing 0.5, which is what you probably got told to do at IGCSE, find 0.5 as well, which is -0.375. That's negative, and the implication of this is to say that the answer is somewhere between 0 to 0.5, or the root is between 0 and 0.5. That's a conclusion you can draw. So there should only be a pair of values, one positive, one negative. You can, with A-level, use this function on the table and fairly quickly get down to, we have a change of sign between 0.3 and 0.4. 0.3 was 0.127, 0.4 is -0.136. So that's positive, negative, there's a root in between. Let's see if we can find the next digit in our root then. Now this is the weird part. AC is normally clear all, or all clear. In this mode, on the calculator, it takes me back to the start of the command, but it hasn't cleared it, it keeps the same settings. So I can now say, keep the same function. Instead of going between 0 and 1, we now know the answer is between 0.3 and 0.4. So 0.3, 0.4, and we do a step of 0.01. And again, I get a list of 10 numbers. You would probably be told, and we need to this time anyway, so we now know that there is a change of sign between 0.34, 0.35, 0.34 was 0.0193, and 0.35 is minus, that's not showing too nicely, minus 0.725 by the looks of it. My graphic seems to have got slightly messed up. Just see if I can get the display a bit bigger. Yeah, the display's a bit messed up. Oh, I see what it's trying to do. It's doing 10 to the -3. It's not doing 0.125. Okay. So we know the answer is between these two values. So that's an O. 0.075, 725. So it's 0.007. And that's negative, so it's a positive and negative. The root is in between these. What this actually tells me is to one decimal place, we have the root is 0.3, because this knocks out the wrong answer. And if I want to go one more place, I try it. And I'll show you quickly in a minute how you could do something similar. I want to try a number between 0.345. So I'm going to go back into the mode, find the comp, and say I want to store 0.34 and store it into my calculator, into memory X. I can then put in the equation, and this is if you haven't got that table function. This is the way you can do it. X cubed minus 3 alpha x plus 1. When you do it the first time, there's my 0.34 answer. If I change that to 0.35, shift store into x. Now I don't have to type the formula in again. What I can do is go back and recall the previous command, press equals, and it now recalculates it. I turn that into a decimal, and mine's set up to do, for some reason it's doing these rather than decimal places. So I've now found that number. If I wanted to find between 0.34 and 0.35, which one is better? 0.345 is the number right in between. Store that into my memory X, and then step up to find the equation and calculate that one. And this is positive. And because that's positive, what I can say in my answer, 3, 4, 5, it's definitely positive at 0.006. It means that the solution is closer between these two numbers to 2 decimal place. We now know that the answer is between 0.345 and 0.35, the two values that change. So that one was positive, this one was negative. And to 2 decimal places, this is my solution. Okay, that's using roots by finding trial and improvement, checking signs, and that's the method.